All right, and welcome to another edition of the Binding Status. I am super excited to be back this week. We've got a lot of great stuff happening around Crossplane right now, especially with our Community Day coming up next week. We have a lot of great speakers at that, and I will talk about that later on in the show. But I want to make sure today that we focus in on Nats, which is the project that we're looking at today. And we have the creator of Nats and the founder of Synadia, which is kind of the company that's building a product around it. Derek Collison on the show with us today, and we are super appreciative of him joining. And so Derek has done a lot of things over the past few years, and he's been on the CNCF TOC. He's worked at a lot of different companies. He started his own companies, as he's doing now. And most notably, what we're going to talk about today is he is the creator of the Nats project, which does a lot of awesome things, which we're going to explore only a fraction, unfortunately, today because we only have an hour. But we're going to see how it works together with Crossplane, how it works with Kubernetes, our general topics on the show, and then also how it will go beyond the scope of that. So, Derek, if you want to jump in and kind of give a introduction and chat about anything you want to, the floor is yours.
Thanks, Dan. I appreciate it. Thanks for having me on. Yeah, looking forward to the conversation. Been doing distributed systems now for almost 30 years. So lots of scars on the back, so to speak. And I think we're at a fascinating time, to be honest with you, right? I think for those in the audience that can remember back, I was still part of the vertical scaling group when I was actually, in university. And everyone knows that we've kind of moved to horizontal scaling. But what I think is going to happen is in the next 2+ years, you're going to see a massive stretching of what we consider distributed systems today, right? Where it's not just about in a single region, in a single cloud provider, XYZ. It's this notion of how do we actually start stretching things, and where I think you're going to see the drive. The main drive is, especially in the next 24 months, is around edge computing of data, right? So I don't want to have to trombone it all the way back to a cloud provider, analyze it, and 3 minutes later come back and say, oh, you should, turn left. I think the audience is probably well familiar with those types of challenges. But what I think's interesting, and I think where Crossplane fits, where Nats fits, where a lot of these other technologies are trying to push the envelope, is around what does that world look like, right? Because most distributed systems today are distributed as long as they're in the same data center, same region, and things like that. So excited to be here. Thanks for having me. And yeah.
Definitely. I appreciate that intro. Touched on a lot of really good things there. One thing I wanted to mention before we get in too deep is Derek was recently on the Go Time podcast, which I bet a lot of people who watch this show definitely tune into that, as most Kubernetes cloud native folks are interested in using Go. Both Crossplane and Nats are written in Go. And he had a great interview there. I definitely learned a lot from it. And some of the things that we probably won't get to dive into as deep today, you went into a little more depth there. So I definitely encourage people to check that out. Before we get into looking more in depth at Nats, I wanted to give some shout outs to some people in the chat. It looks like Jared joining from San Diego. Jared is a founder of Crossplane and also the Rook project, which is a CNCF project. It looks like Pop is in the chat as well. Go check out the Popcast. It is a newer podcast from Dan, and he has some incredible guests on there, especially lately. So excited to have him on a future episode of TBS for sure. And Mocha's here from San Francisco. She's going to be running our live tweets throughout the show. And Steven, who works on Crossplane, joining from Florida. So anyone else who joins, please feel free to drop your name in the chat, and we will make sure to give you a shout out. Also, as we go along, please feel free to ask questions to either myself or Derek, and we'll circle back around regularly and make sure to answer those. So to start off, usually what we do, and I'll go ahead and pull up my browser and start sharing my screen here, is just take a look at the documentation for the project that we're having on the show today. And I don't think folks will be disappointed by the Nats documentation because, to be frank, it's one of the best that I've seen. There is a wealth of information in here. There's a lot of different scenarios. As I mentioned before, Nats is not just a Kubernetes project. It's a run anywhere, handle communication anywhere. I like the Synadia kind of catchphrase on your website that's connect everything. I believe that's
Yeah,
the GitHub account name as well. So just getting started here, we have some great stuff on the introduction and what is Nats. But Derek, I wanted to give you an opportunity to kind of give your take on what Nats is to you, how it's evolved over time, the mission of the project, the origins, and its growth.
sure. And appreciate the compliments on the docs. The team spent quite a bit of time. We realize, how important the ability to get information and to help yourself and drive into topics and play around with things is. And we started about 2.5 years ago saying we really need to step our game up on the doc side. And we're not where we want to be yet, but I'll tell you, the team did an amazing job. So hats off to all of them for sure. And, it's open source as well. So you see the edit on GitHub button at the top right. So if you see something slightly off, please don't hesitate. Click on that, submit a PR. We usually turn those around very, very quickly and really appreciate all of the contributions. So yeah, to your point, Nats is not a Kubernetes only type of technology. All right, it's a connective technology. My history goes back to late 80s, early 90s around distributed systems and essentially trying to help a company that started out called Technicron, which became TIPCO, work with financial services to deal with the ability to distribute stock quotes, right, in a more reasonable fashion. This was before the avalanche of programmatic trading and things. But those old systems were very much like some of the systems we see, which is all those communications were serialized. It's like a phone call. I call you, tell you what IBM is or Google is, hang up, call the next person. And as the list of people that cared got much bigger, the person who was at the end of the line had a kind of a disadvantage, even when a human was staring at stuff. And with the fin services across the globe knew programmatic trading was going to be a thing, they realized this was not going to scale and do well, right? And so we were generally trying to change it from a telephone call to a radio station that you could tune into, right? And a lot of viewers might understand or have heard of the notion of publish and subscribe. And publish and subscribe is important, and it is the core at the very lowest level of what we do. However, it's not the important part from what can we use this technology to solve, right? I built it and created it to solve problems I had with Cloud Foundry. Cloud Foundry was a platform as a service that I designed when I was at VMware. And it was doing things like addressing and discovery, control plane, command and control, observability, querying, things like that. And I realized that I couldn't find something that was a really good fit. And I had been doing these types of systems for well over a decade. And I said, well, I can just build one. And so that's how Nats came into kind of existence, was to power the way Cloud Foundry communicated. And I think the important part outside of pub sub to up level is that most modern architectures, distributed systems architectures, when they talk about connected technologies, they're doing one of two things. They're either doing a service pattern, meaning I'm asking a question and getting an answer. So think of HTTP REST, gRPC, other RPC things, all different types of stuff. And that is the dominant pattern still in distributed systems. And it doesn't mean that you have to wait for the answer, but you're essentially sending a request and you get a response back. And then, of course, there's streams, and streams are starting to become popular, and things are becoming interesting around streams. What's interesting is that those two dominant patterns, they struggle to do a lot of things when you say, oh, the way I communicate is always one-to-one. It's always assumed to be request reply. And the way I find you is via host name and a port. That's kind of what our whole world's built on. It's kind of like, taking all of our cell phones, throwing them away and going back to landlines where it's like, where's Dan again? Is he at work? Is he at home? What's his phone number? That's the world we kind of live in. And I think, publish subscribe is an answer to that. So it does several things that support that streams and services. The first big thing is that it takes away addressing from host names and ports, right? We call them subjects. Kafka calls them topics, I think. Some people call them channels. That's super important, right? The fact that we're still doing landline calls to home and work where Dan is type stuff is one of the unpopular opinions that I talk about, saying, hey, all this great stuff you're talking about is built on a premise that we should have thrown away years ago, and we haven't. So when I look at connective technologies that drive streams and services, I care deeply about, please do not pin me to a host name and a port. And I understand the viewers are like, but no, it's a load balancer, and then I've got 3 load balancers, and I've got this, and I've got, I understand all of the complexity. I think there's a better answer if you just start with the simple thing of saying, what if there's a different way that I can communicate with Dan, right? And that's kind of the global cellular network in our iPhones, right? I just click Dan. I don't care where you are. I don't care what provider you're on. I really don't care what cell tower you're connected to. Don't care where you are in the world, and it just works. And I think NATS if the audience could take home one point, it's trying to drive that revolution around horizontally scalable modern distributed systems to use those types of patterns versus the landline stuff. So
definitely. Yeah, that's definitely one of the big takeaways that I took away from your episode on Go Time, when you were talking about kind of, we just default to HTTP right now. And you spoke a little bit about why we do that and getting around firewalls and that sort of thing. But as someone who's kind of younger in the industry and, came out of college and just kind of seeing immediately the way things are done, that was kind of a revolutionary thought for me, because, thinking back to, you have a lot of experience with doing IP multicast and that sort of thing, which are things you might learn about in school these days. But you generally go into industry and you're like, all right, we communicate over HTTP. We address you by an IP address and port. We may have a service abstraction like Kubernetes provides, but we're still kind of addressing things. So I think for a lot of folks, especially younger folks in kind of the cloud native community, this is a more revolutionary idea than some people realize. So that's definitely something I took away from it, and really brings me to question a lot of the patterns that I use myself in projects, as well as how I see other folks do so as well. And hopefully,
well, I think,
go ahead.
Yeah, I think the point you bring up is really, really good. And I think it's something that, as I've gone on in my career, I've, gone through waves, right? And the first big wave I went through that, at least for me, took probably to about my 40s, was I was okay saying, I don't know. The wave I'm in now, and the decade I'm in now, I am constantly challenging my own assumptions and also being very critical around my own biases. And what I mean by that is I have a bias that, of course, you build systems like this, right? And that's not the bias of a lot of other folks. And so the team has been, they're challenging me, we're challenging ourselves. And what I mean by that is to say, how do we meld those two ecosystems? So for example, I want to do a blog post called The Life of a Service, and I'm getting close to doing it. But inside of the team, we're already playing with ideas of, what does a NATS client that's considered to be like B2, where you're not saying pub sub, you're saying, hey, is this a service I'm interacting with, or is this, a stream? Am I publishing to a stream? Am I consuming a stream? Am I requesting a service, or am I a service provider? And we've already played around with some code snippets where you can take a full-on HTTP handler in Go that does headers, it does chaining of middleware, it does all this other stuff, and not touch it at all. And say with one line of code, hey, if you see a request show up on foo in NATS, use this handler to respond to it. And you never change, you never touch a line of code. Now, for the audience and the viewers that would say, great, but what does that buy me? We'll look at some of the demos that you have, I think, later on, but it immediately says a couple things. That handler, that application, now can run anywhere. It will automatically scale up and down. You don't need load balancers. You don't need Kubernetes. You can deploy it in Kubernetes, but if all of a sudden you deploy it on bare metal in Europe in a cool little cloud provider that you like or whatever, guess what? It works. And it works out of the box. There's no additional components. There's no sidecars. There's no proxies. There's no all of that stuff. And so in the fictional life of a service, you start to see that very first interaction where you go, oh man, I got to run a NAT server, which by the way, they're super small, they're super fast. But once you get to scale, and we'll talk about some of the demos you're going to be running and the scale that we're actually dealing with underneath the covers. For people who kind of get it, the light bulb goes off. And for us as a team, and especially myself, the light bulb's starting to go off of saying, hey, the tech is really good. We're very biased, obviously, but how do we actually integrate with where people are today? And so you're starting to see a change in at least my approach to things, where it's like, I don't want to have everyone have to rewrite all of their HTTP handlers, right? To expose a REST service on NATs and take advantage of some of the cool stuff. I don't want people to have to figure out how to do crazy bridges from MQTT applications. They should be able to just plug directly in. And so for those that follow us, if you watch the project, that's just really had an amazing amount of velocity over the last 2.5 years since we started Synadia, and it's even increasing, and we're getting super excited, I think. Is how do we meet the ecosystem where it is and add value without saying the proverbial rip and replace, which nobody's going to do, or nobody wants to do that unless they're in so much pain, right? The problem's so hard that they simply can't do it. So why the docs right now, especially, we have a meeting after this one internally about how do we start changing the way the docs start and how they present concepts of services and streams, and how applications, distributed applications, are built using those two fundamental constructs, and where NATS adds value to that. And again, in your demo, we'll point out that the big, huge value that we're starting to see as we're starting to integrate more with stuff that's already existing is this, I call it remotes architecture, and it's a really bad term. Other people might say, oh, edge. But think of a remote as a plant, a factory, piece of software, an airplane, a boat, anything you can imagine, where there's some layers of centrals that have core services, right? And the remotes need to do those, and the remotes might be doing telemetry streams that the core is collecting. The core, again, core is not a singleton thing. For example, earlier this morning, we were talking to someone whose core is 3 different data centers around the world, but then they have 10,000 remotes, right, that they want to be talking and tracking. And so they can do command and control, query observability. And the remotes now are becoming sophisticated such that they want to be able to do their own autonomous messaging. And in the demo that Dan, that you set up, right, that autonomous remote is a Kubernetes cluster, right?
Right. Yeah, for sure. And I know yesterday we had a call and we were talking a little bit about kind of this desire in the Kubernetes space specifically to kind of make smaller distributions of Kubernetes. So we talked about K3S and some of those sorts of things, basically just boiling down to an API server and some sort of key value store, and deploying that on edge devices, basically as an operating system for running services and that sort of thing. And one thing that you alluded to already is later we're going to talk about leaf nodes and how within a Kubernetes cluster, in this case, or wherever your remote is, basically wherever you have a NAT server running, you can have this kind of global super cluster, and then you can also have your local cluster, which means that your services in that local cluster are going to continue to operate even if you lose connection to the global. So I think earlier you said, you mentioned like self-driving cars or something like that. That really sticks out to me as a case where you can't just have where your services stop working when they lose connection to the global cluster, to the data center. They have to be able to continue to communicate. So I think there's going to be a lot of use cases for this. So it's going to be exciting to see how NATS continues to support that.
Yeah, no, I agree.
For sure. All right. So there is, like I said, a lot in this documentation here. And I'd encourage people to go through it. It definitely helps me get up to speed really quickly here. If you're specifically interested in Kubernetes, there is a whole NATS on Kubernetes section. And we're going to go through that in the demo a little bit today. Before we get kind of into the demo and a little bit more technical discussion, I want to talk in general about kind of your attitude and outlook on open source. Obviously, NATS is a CNCF project. You have background being on CNCF TOC, and then you have a company that you're building kind of around this as well with Synadia, which we'll also look at in a little bit. what's kind of like your general outlook on open source and how you think Nats fits into that, and how you think companies can be built successfully on top of open source projects?
Sure, I think that's a great question. Just one small clarification: I was never on the TOC. I was part of the
Okay,
founding governing board, but now
gotcha.
I'm just a one of many project maintainers that exist inside the CNCF. Um,
Gotcha.
one interesting thing I think from my perspective of looking and being involved in our ecosystem now for approaching 30 years is I've got to see a lot of trends and shifts and things play themselves out, right?
Hmm.
Closed source to open source to which license are you using for open source, and now to, hey, it has to be open source, has to be liberal license, and it better be part of a governing body. And the governing body part is, I think, the newest evolution from a pure just technical FOSS standpoint, right?
Hmm.
And I think we're still trying to figure out all of the answers to the questions. Um, I do believe there is still value for closed source in very certain pockets, but obviously I've been all in on open source now for I guess it's coming up on 15 years or so, and I believe in it from a um, at its base level. The ability to distribute information about how you solve these types of problems, right? I think it's an amazing technology. Where I think we're being challenged from a, hey, how do we grow? How do we keep figuring out this landscape? Is what roles do the governing boards play? How do they help the end ecosystem? How do they help the project maintainers? How do they kind of do that? And I think some of these are so successful, including the CNCF, right, and the LF, that they're suffering like anything else from growing pains, right? The bigger one that I concentrate on, especially as someone who started a company around open source, is um, the psychology of consumer biases. Now, I know that sounds weird, but I'll explain what I mean. Um, I don't care if something is open source. If I can't out innovate the competition, whether it's closed source, open source, right, I shouldn't win. Um, I don't have a problem with that. I believe in that. I believe smaller companies can still do great things. I was keenly aware in earlier in my career that the majority of the technologies that we all based almost everything in the computer industry were usually started by teams of 3 or 4 at max.
Hmm.
So if you go back and you start looking at this, so that type of innovation and such, especially with the ability to access so many resources now and so much information. It used to take me 2 weeks to figure out something on my Commodore 64 because I just had to kept trying stuff and failing and falling asleep at 3 a.m. And now you Google it, you get a YouTube video, you sit for 2 minutes, you go, oh, that's how you do it. But what I mean by the consumer bias is the consumer bias around how do they value that technology,
Hmm.
right? It's open source, but there is still a value. And I still think there's massive opportunity to attach um, financial pieces to that value. The problem or the challenge from my perspective is if you innovate and you do something really, really cool, um, but one of the big cloud providers or big companies spends $50 million on a similar type of tech, and they just open source it and they don't care at all about making any revenue.
Hmm.
That's okay. I don't have a fundamental problem with that per se. What I'm challenged with right now, and I don't know the exact answers, is when that institutes a consumer bias of zero, meaning the
Hmm.
consumer says this should be totally free. I'm not paying anything for this. I might
Right.
pay for training or consulting or maybe a little bit of education, but heck no, I'm not doing any of that. You know, and we see that, right? When large companies that make massive amounts of revenue, um, through ads or through whatever, say, oh, we'll open source this thing.
Hmm.
Um, that I think is something we have to figure out. And I've the thing that you posted, which I agree with, and I'd love to have a conversation with more folks. And I know I'm as I'm getting older, I'm getting a little more fickle, but I really looked really hard at this for many years, and I still believe there's only 3 ways to make money on open source: bundle it with hardware, And by the way, the reason I say that is because it immediately switches your consumer bias, right? If I
Hmm.
put $400 million of software into something physical that you say, oh, I got to pay for that, might be $2, might be $4, but you're not saying it's free, right?
Right.
So it immediately switches that consumer bias. Run it as a service. That's the SaaS model. And I do believe there's a huge amount of value there. I'm concerned around incentivizing the wrong behavior if you look at it too simplistically, meaning we
Hmm.
created something that's so complex that you can't run it on your own, so you'll pay us to run it type stuff. Meaning that's early on, we tried that simple model of silo, run a server, we'll run it for you type stuff. And everyone that we talked to, it was an absolute failure, by the way. I mean, total flop. I think we had 3 customers. We're very nice and said, look, we love the tech. We love you guys, but this makes no physical sense to us whatsoever. We
Right.
click a Docker image, 2 years later, we click your next Docker image. We don't even monitor it. It just kind of works. And so if that system, when you look at it kind of in a naive way, is incentivizing, oh, let's make it more complicated. Let's make it buggier. Let's do this. I am concerned about that.
Right.
The third rule, at least that I have, is augment with a service. And a lot of people challenge me on this around, oh, that's open core. And I say, I don't think so. It's kind of like the cellular service you have with your phone, right? Your phone is one thing, and the cellular service is an augmentation to that, and it makes it better. And you can do lots of different things with that. And so for me, all 3 of those apply to Nets, right?
Hmm.
We plan on being ubiquitous, meaning streams and services, any cloud provider, any deployment platform, IoT, edge, web, mobile, you name it. And so bundling with hardware, I think, is in our future, not in the near future, but it is. But running it as a service and augmenting it with a service is the biggest ones that I think we're driving. And again, I know there's going to be a lot of viewers that disagree around the open core, and that's totally fine. I think what's amazing about our ecosystem is everyone can have diverse set of opinions and debate in a great way. I simply, because I've been around for so long, look at open core as just a repackaged version of freemium enterprise.
Hmm.
And premium enterprise failed, right? And so I can't imagine open core surviving unless it changes, And the other thing too is before things like Kubernetes came along, there was large opportunity to say, ooh, they're not doing monitoring, or they don't have cool admin dashboards, they don't have this, they don't have that.
Hmm.
And someone could make a business, and it wasn't going to be a 100-year business, probably wasn't even going to be a 10-year business, but you make a business out of that, and usually get bought by someone that wanted to do a commercial offering.
Right.
These days, especially with the Kubernetes ecosystem, I watch them where when it first released, they didn't have good dashboards, monitoring, all that other stuff. And the ecosystem swelled so fast that they simply filled that void.
Hmm.
Meaning in my opinion, there's not a business opportunity around doing those types of things for Kubernetes. Now there's definitely, the ecosystem is big enough now that there are opportunities to do things like Crossplane's doing, for sure. But again, I think those 3 models are the main one. And again, if people want to take home a take-home point, I challenge you to think about the things that drive consumer bias to think something is zero, it's free.
Right.
You know,
Definitely. There's a couple points I wanna hone in on there. First, you said at the beginning what a great learning source that open source is, and I would definitely echo that. I think there's a lot of things that just in the year or so that I've been fully in the industry, where I've learned so much just because you can look at the code, right? There's no abstractions that you're being held at arm's length with. You're actually able to look and see what's happening. And if you have the desire, you can get involved with that. So I definitely agree with that, and I think that's one thing that often gets overlooked, and is probably one of the greatest pieces of value that open source brings. And when we're all able to learn a lot faster, then we're able to produce more. And I think that's also in support of smaller teams building open source projects and then monetizing them that are successful, because there's more knowledge, right? It's not being focused at a large company where all the good engineers work, and it's being put in one place. There's opportunities for lots of people to access things, to come up with their new ideas, to bring their perspectives, and that sort of thing. And the other
sure.
thing that you talked about was kind of this, open core versus augmenting a service versus providing a service. That's definitely something that we look at a lot at Upbound. with Crossplane, and thinking about, especially for myself, working pretty much exclusively on the open source side, treating like kind of your company as a customer, and then also thinking about what is something that is enabling people without taking away value from the open source side of it. So a metaphor that you used once again on the Go Time podcast was talking about giving someone a phone and then giving someone a phone with like a SIM card that allows them to connect, versus giving someone a phone and then giving them a battery, right? So the phone without the battery is completely useless. A phone, without a SIM card, is very useful. There's a lot of things it can do. It's a very powerful computer. It's a powerful piece of technology. But then when you connect it to other things, and we'll see that I'm kind of alluding towards some of the stuff Synadia is doing here. But I thought that was a really apt analogy for what it looks like to not have an open core model, but to augment with a service that enhances the usability without actually adding more features to the core product itself.
Yeah, and I think the augment with a service, the lines of what's open source and what's not are extremely clear. They're built in, right? You don't have to kind of explain that away. Now, to be honest, I'm not saying that open core doesn't work today, right? If you can look at lots of different companies. The one that I concentrate on mostly these days, from that perspective, that's doing it right, is HashiCorp. And one of the things that I think HashiCorp has proven, Mitchell and Dave and company, is that they can adapt, right? So if open core starts weaning, and kind of slowing down, I have no doubt that they will keep on and growing and succeeding. The other one too is it's like if, and this is a pet peeve of mine, but again, it's that consumer bias type of thing, but it's slightly different, which is, we get a lot of people that will just look me straight in the face and say, "We love your tech. We've spent 10 years on it. I've spent 10 years on it. All in, we're in the tens of millions of dollars of investment. That's not counting time. That's just dollar type stuff. I mean, it's good stuff." But they look at me and say, "It never fails. It just runs. Why in the heck will we ever pay you support?" And they'll look right in my eye and tell me that. Even, crazy mission critical production systems. And that's another bias that I think is interesting to challenge, which is the support isn't for you, the consumer. You think it is, but it's kind of like the doctor is for you, or your health insurance is for you type stuff. If we stop looking at it more from a Western perspective of, I will pay support because it's covering me, and say, I pay support so that I don't get sick, right?
Right.
In Asia Pacific type countries, a lot of times doctors actually get paid when you're well. And when you're sick, they don't get paid because they're not doing the right job. And I don't know if that's the exact metaphor, but there is something around people need to view support of an open source project through a support mechanism as not for them.
Right.
It's in support of the people driving the project and making it a quality project that adds value to you as a company, right? And you don't want to have to call the phone number or send the email or whatever. And we want to incentivize that behavior. Like I said, my fear is that parts of the ecosystem, we have set up the wrong incentives. It's incentivizing the wrong behavior.
For sure. There's some great points. I want to go ahead and, since we're about 40 minutes in, there's some other things I want to talk about. And I think we could probably have a conversation all day about a lot of these topics, but I'm going to start off by jumping into the demo a little bit, and then we'll come back to talking, because we're going to be provisioning some GKE clusters here that take a little bit of time to come up. So I want to go ahead and get that process started, and then we can circle back around to some conversation.
And as you're doing that, maybe what I can do for the audience is, as Dan's spinning these up, is, there's two major facets in that ecosystem. There's the clients. I think we have 42 different client language implementations now, and that streams and services that we talked about earlier. The second piece that is kind of ubiquitous and underneath the covers is the servers. And don't think of this as your old message broker or enterprise service bus type stuff. Think of NATs as cell towers, right? The cellular network, meaning they're lightweight, they can run anywhere. You can connect them in lots of different ways, like Lego bricks, and you can essentially create any arbitrarily complex topology that you need, even at global scale, which we'll talk about, to do what you need to do. And so, similar to your phone application and your phone doesn't change if people are putting up new cell towers and changing things around. NATS is the exact same way. When you write the application, it will run and it will continue to run as you're changing the topology. And what I think Dan's going to highlight here is the ability to say, hey, on day one, we start with one little local server, right? Then we might make a cluster. A cluster is kind of distributed systems of today, which is, hey, put me in the same region. I want to have good throughput, low latency, good signal to noise ratio. Then that says, oh, but servers can also talk to each other across gateways, which allows you to form super clusters. So clusters of clusters now. And we run one that spans every cloud provider in every major geo, meaning Google, Amazon, and Azure, West Coast, East Coast, Europe, and Asia Pacific. And then the last way to connect into this super cluster is to do a hub and spoke leaf node. And what's interesting about leaf nodes, it's kind of like being able to put my own cell tower in my backyard, and it works really good when I'm in the house. But as I drive down the street, I still just connect to the AT&T cell towers, and all just works. And so NATS and the way the NAT servers can be put together forms this. And so if you can imagine global topologies or edge technologies or this remotes architecture we talked about earlier in the call, that's where NAT starts to really shine, right? It's that, oh, I got a single technology to, services and streams. Oh, they've really thought hard about security. Our systems never have passwords or keys in them whatsoever. They've really thought about multi-tenancy. It's a true, real, secure thing in their system, meaning I call it the Coke and Pepsi problem or UPS and FedEx problem from the 90s. And these server topologies, these NAT systems can be continually changed and you can scale them up and scale them down and add different components. And the applications, except for where they connect, think of it like your phone figuring out what cell tower to connect to, they don't change. Nothing changes about them. So.
Definitely. Yeah, I think that's a great point. I'm excited to show off some of that. While Derek was talking there, I ran through a few things that might be new to some folks so as we've recently kind of changed some of our provisioning model with Crossplane. But as I've done on most shows, start off by installing Crossplane and provider GCP. So basically bringing along those CRDs that represent managed resources on GCP and the controllers to manage them. And then the new kind of way to provision things, which we're calling composition, allows you to kind of define your new infrastructure type. So before, Crossplane brought along claims for things like a Postgres database or a MySQL database, and then those would bind to manage resources on a cloud provider. So think of a Cloud SQL instance, an RDS instance, et cetera. It's really difficult for a single project to maintain all the different kinds of abstractions you may want for infrastructure. What that also did is precluded you from bringing together multiple types of services to form a higher level infrastructure unit. So you can think of some of the examples we have in our new quick start guide are things like provisioning a database with a firewall rule in a network and connecting that all together all at once. And then you may want to call that, secure database and want to be able to create secure database instances in your cluster. And on GCP, that may look like creating a GCP network, some subnetworks, some service connections, and then creating a database. On Azure, for instance, you have to create resource groups. You have to be able to create a SQL firewall rule. You don't have to worry about the network if you want it to just be publicly available. So there's kind of different things that you need to do for each. So what you're allowed to do now is define your own infrastructure type. So you'll see I started off by creating a cluster role for a new type that we actually hadn't created yet. And it's just called Kate's clusters. So anything that basically satisfies this interface we're creating to be a Kubernetes cluster is going to be able to be used here. And you'll see when I define the new Kate's cluster type, you kind of have this inline CRD here that allows you to say, these are the fields that I want to be able to configure on the resource or the group of resources. And then I also want this connection information back. You'll see all we need when we provision a Kubernetes cluster is the kube config there. That contains everything we need. If it's a database, you may say, I need a username, port, host name, etc. Basically, anything that satisfies this is going to be able to be created with this abstraction. So one thing that we can create here to satisfy a Kate's cluster abstraction that we've defined would be a GKE cluster. So you'll see in this composition, this is a very simple one, and I'll show a more complex one here in just a minute. But all we're saying is this kind of primitive managed resource that GCP provides when we install that provider of a GKE cluster. We're saying this is basically the default configuration here, and then we want to bring these parameter values from the abstraction and plumb this up correctly so the user gets a Kubernetes cluster that they can connect to with this kube config secret, as well as know that it's going to be in the correct location and have the right number of nodes. Those are the two parameterized fields that we configured there. If you look at the new Crossplane documentation, for instance, which I will bring up here quickly, you can see that this doesn't have to just be one resource that you can configure. So in our documentation, we go to this published infrastructure section. Here, we're creating an abstraction for Postgres databases, saying that we're just going to define the size of it in storage GB. And then we have things that can satisfy this on different cloud providers. And you'll see GCP, it's just a Postgres instance. On Azure, we're creating a resource group, Postgres server, and a firewall rule. And then we're selecting where that connection information is coming from. So much more powerful model. Just wanted to demonstrate that a little bit today. And then we can create namespace versions of these at the namespace scope, obviously. So you'll see here, I'm just creating a K8s cluster requirement. I'm using the label selector to select GCP and providing location and nodes. So we could obviously also have, an AWS version of this, an Azure version, or we could have different labels that say, large, small, etc. if we want those to be more abstract things you can parameterize. Then what we see rendered out here are actual GKE clusters that are provisioning on GCP. So let's see what their status is. It looks like they're both synced and running. They're created in the default namespace. So if we look at the secrets, we should see secrets that just have one field. Yep, we'll see K8s Central and K8s West. And now we can actually connect to these clusters. So Kubernetes, Crossplane spun those up. And now we're going to get to do some pretty cool things with NATs on these clusters, as well as from our local. And to kick that off, we've kind of alluded to and talked about this hub and spoke model, this global super cluster that Synadia is working on. So I want to hop over to the Synadia page here and take a look at NSG here, NGS, sorry, I keep mixing that up, NGS. And Derek, I just want to give you the floor to kind of talk about what NGS is and how it kind of plays really nicely with NATs and how it kind of fits into some of that open source monetization strategy that we talked about earlier.
Yeah, thanks. So NGS is completely built off of all the open source. It is a global supercluster that's available through a single URL, but in every cloud provider and in every major geo. Where I think it becomes really interesting, and Dan's going to show you this, is that even inside of an organization, so forget about Synadia or NATS for a second, inside of an organization, there's a lot of patterns that will look like this. Hey, let's try this new tech. Let's do POC 1, let's do POC 2, POC 3. Someone then raises their hand and goes, hey, we've got 3 silos. Why don't we create one that we can all share, right? And it's usually an either or conversation. And to be honest with you, at least from my perspective, they usually fail spectacularly. The people who are invested in the shared utility are all in, and the people who say, screw you, I'm going to be running my own servers and my own tech, piss off type stuff, are always at odds. And so one of the opportunities we were looking at with, hey, we have all these different ways that servers can kind of be Lego bricked together. What if we do one that allows this hub and spoke, meaning it allows you to extend an existing supercluster, but also allows you to mix operators, meaning who's running the servers, and security modes, meaning I can pick my own security. Let's say it's physical host access to my machine, or it's RBAC based on a Kubernetes cluster for a namespace where NATS is running. And I can extend that public utility. So don't think of it necessarily as NGS. Think of it as your big company saying, hey, we can do both. We can have a group that's actually setting up a shared utility, right, for all of our different data centers and cloud providers. And then if a group says, yeah, but we have super high-end requirements for latency and throughput, and we want to run our own servers, it's not an either or, it's an and conversation. The other thing too is that today NATS is considered a messaging technology, and we term it as a connective technology. But at the end of the day, when you peel back the onion of almost everything, distributed systems are all just message passing. That's all they're doing. Your CPU cores, the way they're figuring out L1 cache lines, is all message passing. And so what we've started to look at is, hey, wait a minute, what happens if NGS has that dial tone, has that, oh, I can connect, and the single URL does all the DNS, geo, cloud provider, pinning, all that kind of stuff. So it does the right thing for you. But what happens if, the system, then I can import a service that I click a button and now all of a sudden I can send a message to kv.set or kv.get and do secure zero trust KV, storage anywhere in the world, any deployment platform, any cloud provider, edge provider, top of rack switch, telephone pole, doesn't matter. And so NGS is kind of that, running that, NATS as a service, but again, it's not a silo. It's this massive global utility that's going to be hard for people to reproduce. But they can, but it's going to be like not fiscally responsible to do that. But we're also going to start adding services in that like augment. So our upcoming Jetstream technology, which does streaming like Kafka and persistence for things like our MQTT client integration that we're doing. KV, object storage, maybe GraphQL where it's just you're sending messages. And again, we haven't touched on it a lot here, which is totally fine, but the simple applications that you can run are extremely secure, right? So we do all of the best practices. We do signature signing. We never share private keys, passwords with the core system. So there's a lot of really interesting things that you can say, oh, I don't have to go back and do a 6-month audit about how do we secure this thing. You're secure by default on day one. And so that's kind of the offering, but I want the audience to think of not as NGS as an offering, although it is, and you're welcome to use it. And we actually have generous free tiers that you can do all kinds of crazy stuff and probably run your whole company on it. But as hey, this is a way to take connective technologies that don't pin me to addressing and discovery by host name and port and run that at a global scale securely with true multi-tenancy, meaning I have my own sandbox, I can do whatever I want. And they allow me to extend it. So I can actually have the shared utility model and I want to run my own infrastructure stack, and you can mix and match those.
Definitely. Yeah, and I can definitely speak to the generous free tier and getting up and running quickly. I'd encourage people to look at this getting started page. Basically, you install a CLI and it does all the work for you and you're good to go. So really, really cool setup there, really good user experience. And we're going to show that off a little bit here. We are going to install some of these leaf nodes that we talked about earlier into the Kubernetes clusters we've created. I also wanted to point out that there is a NATS operator project. So if you're familiar with Kubernetes operators, which most people who tune into this show likely are, feel free to check this out. It's the usual experience where you're going to get a NATS cluster by basically creating a NATS cluster CRD. So that may be useful for some of you folks. And I wanted to point out the work that's happening there.
Yeah, and for the folks that are on who have interest in this, right? We're both looking at this stateful sets, Helm charts, right? It's still kind of a fluid environment, I think. But our point, who hopefully people know, but if they don't, is Wally. We call him affectionately Wally. But find him on Slack. He's all things Kubernetes and all this other stuff for NATS. And even for this one, he did that Helm chart, right, that we're doing now. And again, the only other thing I'd point out for the audience is that when we talk about leaf node servers, just know that all the servers are exactly the same. They're all the exact same open source code. It's what role do they play in terms of extending a supercluster. But when you run a leaf node server, it's a full-blown server. A single server on modern hardware can do 20+ million messages a second. So I mean, it is definitely extending the supercluster, but you can essentially power a Kubernetes cluster with thousands of pods and crazy stuff going on with one NAT server. And I promise you, please tell me if I'm wrong. It'll absolutely flat out kill any other thing you have from an OpEx, both performance and cost perspective. So yeah, so leaf node servers are its role, but it's a full-on server, the exact same one that we're going to be connecting to, or the cluster of ones that we're going to be connecting to.
Definitely. And I know my first thought when you were kind of telling me about this leaf node setup here, well, I think my question was, oh, okay, is that just basically a proxy for connecting to NGS? And you're like, no, that's kind of what the value is here. Is it's not. It's its own server. It's running NATs itself. So if we lost connection to NGS or some other global supercluster that we had, services that all exist in that cluster would continue to communicate because they have the full-blown NAT server right there, and they can continue with their communication.
The other thing for the audience too that's we don't talk a lot about because this is one of our biases. We take it as a given, but it's not for a lot of folks and other technologies. Is even from day one, we wanted NATs to be a scalable distributed system that was not paging you in the middle of the night. So we spend a lot of time on NATs such that NAT self-heals itself. It's clustering technologies. All of them will put themselves back together. All of the clients, 41 plus or so in the ecosystem, they will automatically reconnect. They're automatically, when they connect to a server, told about topology changes. So as you add servers and take them away, all of the clients know about that without DNS changes and all kinds of crazy propagation type stuff. And so you get a really amazing experience from a production level with security, scalability, mixing, matching utility, and running our own infrastructure. And then wow, it just kind of put itself back together type stuff when something kind of went wrong. And we think that's a big, huge deal for people building these systems.
Definitely. So I'm going to move forward here with provisioning these leaf nodes on each cluster. I just showed a moment ago. Well, actually, before we do that, let's go ahead and get my NGS credentials over there. Since we did provision these with Crossplane, we have our Kubernetes secrets with our kube configs here. So I went ahead and decoded those out into kube config files. So now we're able to do commands to each of these clusters that we've provisioned. So we're going to start off by creating our secrets in each of these clusters. So once those are created, we can use Helm to provision these leaf nodes. And I have the config here. And something to note is Derek mentioned Wally. This is all based off his guide, basically, that you can find on the NATS documentation. So please feel free to check that out. I basically just added in the Crossplane flavor here to spin up some of these kind of remote places to run NATS. So I will go ahead and deploy these to our clusters.
And for the audience, when you look at credentials, you go, oh, it's a username, password type stuff. It's not. Remember, we were talking, the system never has access to private keys or passwords. And so credentials are actually two things combined. And so they should be considered sensitive and keep them secret like Dan is doing now. But what they are is they're a public claim of who you are, what account you belong to, and who signed for you, what you're allowed to send to and receive from. All of your authorization primitives are in a public claim, and then it's your private key. But that private key is never transmitted. What happens is when you connect to a NAT system, the server will provide you or present you with a nonce. And so you're going to send in the public claim that says, hey, I'm Dan, I'm part of this group. And you're going to sign the nonce to prove that you are who you say you are because you own a private key for that user and things like that. And so when you look at creds, think of it as just a very simple way of putting things together, but it's not username, password. It's very different. It's not even bearer tokens. It's a public claim that can be lost and nobody cares because nothing can be done with it. And then of course, the ability for me to sign that nonce challenge that's presented.
Definitely. That's definitely a huge part of it, especially, if something is kind of like brokering a lot of your communication, it obviously has to be secure. So having that confidence right out of the box is super important. What I just showed here is after we deployed the Helm chart for the leaf nodes, you'll see that we have a cluster of 3 NAT server running. And then also this NATS box utility container that basically allows us to have some of the NATS tools available to us, which is how we're going to show communication. So once again, we have 2 separate clusters, one running in the West region, one running in the Central region. And now we're going to run a publisher on one side and a subscriber on the other and show how these are just basically able to connect right out of the box. So over here.
So on this one, Dan, instead of doing sub, make that RPLY, nats-RPLY.
Okay.
And so you're going to send your request on hello and then past hello, just put in something. Crossplane. That'll be the response, right? So this is essentially creating a subscriber on hello, but it's also now listening on a dynamically created queue group. No load balancers are harmed in this demo. And so now you can do a Nats publish for sure to hello, and you'll see it show up there. Or you could say Nats request, so REQ to hello. And what it's going to do is it's going to send that request so do space hi. So it's sending hi to the Crossplane service, and it gets back Crossplane. Right. So this is a trivial example, but think of this as your HTTP service or your gRPC service or whatever like that. And by the way, this automatically is set up so that he can run as many of those Nats reply hellos as he wants in any Kubernetes cluster, any deployment environment, and they all just dynamically scale on a global platform. This is a global platform. So his servers that are running in these Kubernetes clusters are connecting to our supercluster, which again runs in every cloud provider and every major geo.
Yeah, for sure. And I'm actually going to go ahead and get a Nats box here on my local, just in a Docker container. And we can also run one here. So for instance, I can just do Nats request hello, and we'll say bye this time. And it looks like my creds are not right. Let's see here.
So if you use Nats box space Nats request, or
I think it's because I need this here. 1 second.
Okay.
Yeah, there we go. I just mounted them, but did not specify them. Yep.
There you go.
So we got the Crossplane back. So now we have both our clusters being able to talk to each other, as well as my local machine. You know, 2 of them running in Kubernetes clusters, 1 running in a Docker container. Should have set up my Raspberry Pi here and showed that as well.
Yeah, Dan, real quick, run the Nats reply hello Crossplane inside of West Cube as well. So just copy and paste that line, and or if you want, you can say run it, but we'll run it and we'll say responding from Crossplane West.
Okay. So let's say Crossplane West, and let me change that cube config there for us. All right.
So now if you go down to your Docker image and send the request again, if you notice what happened there, he got Crossplane back. And the reason is that underneath the covers, Nats topology. So the applications have no clue about any of this, right? They're just sending a message, expecting a response back. The Nats system is securely connecting to the local server in his Docker container, which is then leaf noded with credentials into NGS, which then will select the nearest responder. And so it's always going to pick the one in central because Dan's somewhere located near the central part. Now, if he goes up to the central and just kills that replier and then runs the exact same command,
there we go.
Now suddenly we get Crossplane West. So what just happened there is we have a secure, global, shared utility extensible inside of Kubernetes clusters that is also doing geo-pinning, load balancing, and DR. And it's all open source. And he's running on, we gave, because Dan's a friend of ours, so is Crossplane and Upbound, we bumped up their stuff, but you can do this exact demo with a free account on NGS, the exact same thing. And by the way, those servers right there, you could, if you wanted to, create, 4, 5, 600,000 connections to them and still have that connectivity to the replier in the Kube Central type stuff.
Yeah.
So hopefully the audience kind of gets a sense, even though it's text and it's command line and stuff like that, the principles that we're showing, hopefully resonates with the audience. It's really, really powerful.
Definitely agree. And hopefully when all of the manifests and everything from this demo, as well as all TBS shows, will be available, as well as a guide to help you walk through them yourself. So maybe I can put together a little architecture diagram to help illustrate exactly what's happening better here, because this is obviously really cool. And I'm glad right before this call, we kind of got this request reply with the different regions and showing where it was coming from set up. So I appreciate you coming in with the assist there, Derek. And it's definitely been, go ahead.
Yeah, one of the other things is on the Nats request where you do that TBS. So instead of sending to hello, so go down to the very bottom window, send to ngs.usage. And AGE space 1H, like 1 hour.
Mm-hmm.
So if you expand that a little bit, that's essentially our usage system, meaning NGS has it built in. And so all you have to do, and you can send 24 hours, 8 hours, whatever you want to.
Mm-hmm.
Here's the cool thing for the audience. It's using all of the same tech that we just demoed. NGS usage servers are running in distributed queue groups all around the world. So you get the nearest one to you. This thing, again, is jumping through all of these different infrastructure points securely to get it to work. But what's really interesting is if Dan describes his credentials and who he is about how he's asking to send to NGS usage, that is an imported service. And the imported service is, the exported one is not NGS usage, it's NGS usage.star, meaning anyone. And what happens is that the system said, I'm going to give Dan a secure token to import NGS.usage. A very long string that's his public account ID. But what's cool about Nats in this sharing that we talked about, this multi-tenant sharing, is that it's his sandbox. So he puts it where he wants. So everyone has it show up as NGS usage. But now what happens is the back end has a secure context-aware request that it gets. It knows it's coming from Dan. So it can give him his usage versus mine. And so that pattern is trivial to do in this system. And by the way, it works at a global scale. There's no, okay, let's have a design meeting about how many load balancers and security stuff and mesh stuff and this and that. And so, we think it's extremely powerful for these types of environments and then extending out to edge and beyond for sure.
Definitely. Well, this has been a super awesome demo. I know we're 5 minutes over time, so I appreciate you sticking around.
Sure.
I wanted to give you just kind of a few minutes here at the end, if you like, if there's anything we didn't touch on, to just kind of talk about whatever you like. And, if there's anything that you're excited about coming up in Nats or with Synadia or anything like that, you definitely have the floor.
Well, again, thank you. Happy to answer any questions. Please, if you have any interest in this, join the Slack group. You can find it on the Nats.io page. We have 2,400 some people, I think, on there these days. We all sit on there. We're all willing to help, and there's no such thing as a dumb question. We want people to be educated. Some of the things that we're super excited about now, we have just an amazingly talented team that are doing just some crazy cool stuff. So we have a Rust client that went from me trying to learn Rust and whack something together to probably two of the top people in the Rust ecosystem now cranking this thing. And we believe that's going to have a huge effect on IoT and embedded types of systems outside of just general goodness. We talked earlier in the call about us looking at redoing the client API to more properly say, hey, I want to create a stream, publisher or consumer. That's kind of work that's going on. We've landed header support, which I promised I would never do. And I lasted for about 10 years, but that's all part of our notion of how do we embrace the ecosystem that exists today? All these microservices that are either, HTTP handler based and the protobuf is what's being encoded. How do we actually embrace that and take advantage of that? So the header stuff's coming very shortly. It's already kind of landed in the servers. The servers have to support it first. We've got Ari, who's based out of Europe, working on Jetstream, and Jetstream's our streaming and persistence engine. It's built into the exact same server. So remember we said, don't think of a leaf node server as a little proxy. If you actually built for master, that leaf node could actually run full-blown Jetstream, which can do streaming, limit-based, evictions, different consumption models, pull, push-based consumption. That's all there. We've started work on MQTT, right? So eventually you'll be able to take an MQTT app and point it right at any NAT server, and it just works, meaning we will give MQTT applications and IoT applications access to an instantly secure global hyper-connected system. We landed WebSocket support, but we just put it into master, so it's coming very soon, but you can play with it today. That opens up web and mobile. So we're excited, right? We're not sitting still. We're trying to push both in terms of where we think people want these types of technologies. And we're excited. So thanks for having us on. Big shout out to the team. I get to talk on a lot of these, but it's an amazing team of folks that are driving a lot of the cool stuff. And definitely go and find them on Slack and talk with them. We talked about a little of them today. So
definitely. Well, we really appreciate you coming on, Derek. I definitely personally preparing for this and going through this, learned quite a lot about NAT, as well as just the kind of ecosystem around it. I'm definitely excited to start using it on some of my personal projects. Also, kind of excited to see how it could enable some multi-cluster stuff in Kubernetes. So, lots of cool
Yeah.
things coming up there. So, I'll definitely try and jump in and contribute where I can. But yeah, we really appreciate you coming on. And with that, I think we'll go ahead and wrap up the show. So thanks, Derek. Thanks, everyone in the chat. If you want to run through these demos yourself, they'll definitely be available in the TBS repo under the Crossplane org. So check that out. And I hope everyone has a good rest of their week and a good weekend.